Vertical lines are a special case. Let's go ahead and look at the slope of the graph first. I'm going to pick any 2 points, and here I do have a rise, but what is my run? What is my change in x between these 2 points? Between these 2 points, there is no change in x. X remains constant, and in fact, the run of every vertical line is 0. So even though my rise is 3, that doesn't really matter because any value divided by 0 is explosion of the universe, explosion of your calculator. You'll get an error because you cannot divide by 0. Any value divided by 0 is undefined. Therefore, the slope of a vertical line is undefined. We could also find this from the table. X is going up by 0. So when I try to divide my change in y by my change in x, I get 1 divided by 0. Again, that's undefined. This is where we have a little exception because we cannot write the equation of a vertical line in slope-intercept form. The slope is undefined, so I don't want to write y equals undefined x. And there is generally not a y-intercept. This line does not ever cross the y-axis. Therefore, I have a very similar form to my horizontal equation form, whereas every point on this horizontal line was described by the fact that y equals 4. Every point on this vertical line is described by the fact that x equals -3. So look at the graph. Every single point on that line has an x value of -3. Look at this table. Every single point in this table has an x value of -3. This is something you kind of just have to memorize. Every vertical line is an exception. It cannot be written in y equals mx plus b form. Instead of writing y equals, this is our only line that we will describe as x equals. X equals, in this case, -3. You'll just have to look at the table or the graph and find the x value that characterizes every point on that vertical line.